Hi everyone, this is Ashnat Kothari here. So in this particular video, I shall be discussing the indicative solutions for CS2 A for IFoA September 2022 session. Let me update you all. We would also be releasing the indicative solutions for paper B sometime around mid-October. Um, Now, as for the paper CS2A, again, I will say this was a tricky paper. There was a heavy weightage of time series questions, and I mean, probably we had around three questions worth 35 to 40 marks from time series alone. So some of you were taken a bit surprised by the sheer quantum of the marks devoted to time series in paper A. So we will look at the each of the questions, and I'll also discuss where students generally struggled and all. So before that, don't forget to subscribe to our YouTube channel so that you all are updated with all the latest content we release. And if you find this particular video useful, please do like as well. And in case you want anything else, feel free to comment on this particular video. Also, in case you feel that any of the solutions which we have discussed is not correct, or if there are any sort of calculation mistakes, please let us know through the comments section. We would be taking a look at it. In case we find merit in that, we would be pushing in the rectifications through comments box and pinning the particular comment. So for all the viewers of this particular video, the way to go about is that always take a look at the comments section as well while going through the video, so that in case we have pushed in any sort of corrections, you are aware of that as well. And we hope that through this video, you would be in a better position to judge the tentative marks you could score in CS2A and decide for the next papers accordingly. So before we get started with the discussion of the solutions, let me also just inform you. Uh, Recently, the results for IA July 2022 session had come out. For the fourth consecutive session, students from Finatics have secured All India Rank 1. And this time, instead of one student, it were two students, and that too in two new papers of CB2 and CP2. So in total, from 2020 onwards, we have had five All India Rank 1, if I'm not wrong, or maybe even six. I guess six it is, sorry. First one was CS2, then we had three back-to-back toppers in paper CM2, and this term it's with CB2 and CP2. Something to do with probably the number two, I guess. Hopefully going forward, we might have students securing All India Rank 1 from papers like CM1, CS1, CP1, and so on as well. So that was it. And, as for the new batches for April 2023 session, we shall be starting from October 9. It had been postponed from October 2 due to a lot of festivities in this particular week. So we had decided to start with our session on October 9 itself. Classes are available in live offline mode, currently at Calcutta only, live online mode, as well as pre-recorded lectures. All the students who are joining us will be getting access to all these three. There are no additional charges. Again, irrespective of wherever you are, your concepts and your doubts are going to get cleared, whether you attend offline, whether you attend online, or through the recorded content we give, or through our doubt support group. So location shouldn't be a barrier as long as you know English, which is the primary mode of medium. It should be fine for you all to join our classes. Again, some of you have asked me why don't I teach in Hindi, and if we ask doubts in Hindi, will I clear or not? Definitely, I would be taking your doubts. It's just that the examinations are in English, and conversing in English, explaining English helps a lot from your exam point of view, because other than that, there is a two-layer thought process. First, you might think or understand certain things in Hindi, but at the time of exam, you might have to translate that into English, and that consumes a lot of time. As a teacher, it's obviously, I'll say way easier for me to converse in Hindi itself, being the mother tongue. But for your own betterment, so that it saves a lot of time while you are sitting for the main papers, conversing in English and trying to explain the concepts in English is what I look forward to. And for some reason, if we are unable to make you all understand something in English, feel free to ask in Hindi as well. We would be, anyway clearing it out in that as well. So it's not that we won't use Hindi or anything like that, just that the main medium is English, so that students from outside India as well as students from India who do not speak Hindi, they are comfortable. And more importantly, I'll say, you develop this knack wherein you are thinking at least for your education part in English, so that the time you will take to translate your understanding in Hindi into words in English, that is completely removed, and you use your time efficiently during the particular exam. So this was regarding our classes. Coming back to the paper, let's start with question one. I'll try to keep the video as short as possible and we cover all the possible solutions. So this is question number one. These are the various equations which we are getting. So gamma is coming out to be 0.925579104, and this is the value of C. Next, we want probability x greater than 1000, and the answer is coming out to be 42.65%. Next, we have question number two from time series 9 marks. Part 1, 2, and 3. So many students, I'll say, did struggle in part 1. Part 2 and 3 were fairly straightforward. So let's take a look at the solution. So I've rearranged the equation in this particular format. For the process to be stationary, I want that the roots of this characteristic equation, which is this, all of them must have a modulus of greater than 1. Now, on solving this, the result which I'm getting is mod alpha is less than half, and B can take any value. It does not affect stationarity as such. For part B, for the process to be invertible, the value of A does not play any role as such. It's basically this equation. The roots of this must be greater than 1. So therefore, what we have is mod B must be less than 1. A can take any value, and therefore the process will be invertible. For the third part, we want it to be an I1 process. Now, for an I1 process, basically, let's say lambda equal to 1 must be a root. So one quick way of doing that is that the coefficients of xt, they must all add up to 0. If that is the case, then yes, 1 minus b is the root of that particular equation. So over here, 1 minus a minus 0.5 is equal to 0. Solving this, we will get a as nothing but 0.5. And the other root you can check, that should, if I'm not wrong, come out to be as 2 itself. So, therefore, the resulting process will be an I1 process, wherein if you difference the process once, the resulting process is a stationary time series process. So A will come out to be half, which is for the third part. Next question number 3, 10 marks here again. For the first part, if you could realize, that this expression, although it might seem as MA infinite, but if we'll try to connect, we can express AR1 process as MA infinite. So for part 1, there are multiple ways. One way is you just expand this, you find its variance, covariance, mean, and then you try to show that xt is stationary. Alternatively, what I have done is another way. I could recognize that this is nothing but an AR1 process, and then I use the properties of AR process to check for its stationarity. And Markov property is something which is inbuilt in AR1 by definition, or AR1 process by definition itself. So let me take you all through the solution for that. So this is xt, written down explanation so that you'll understand. This is another way to express AR1 process. I was very, positively surprised looking at one of the students being able to solve in this particular way. Didn't expect many of them to, use this approach, but yeah, in fact, I did find one student using this particular approach. So this is nothing but an ER1 process of the form xt equal to 0.5 xt minus 1 plus et. And then, I have actually shown how we get this as well. Because in examination, I'm not sure whether just stating this will fetch you full marks or not. So for completeness, I've shown as well. So here, if you just go about, bringing all the xt terms to one end and then taking this 1 minus 0.5 b to the power minus 1 at the other end, expanding it, you'll find in this particular form. So now we have stated that the particular process can be restated in this form. I need to find its characteristic equation. The roots are coming out to be 2, which is more than modulus 1. Therefore, xt, which is AR1, this is a stationary process, and we know that AR1 also possesses Markov property. The same could be explained through words as well. If we know the value of xt minus 1, we are in a position to determine the properties of xt, and therefore there's a one-step dependency only, not more than one step, and therefore this will be a Markov process. Part 2, we have yt as xt minus 0.3 xt minus 1. My xt, I can also write this as 0.5 xt minus 1 plus et, so we get in this particular form. I try to find expectation yt. Okay, so for that, first I find expectation xt. Next, what I do is find variance of xt. Once I have that, I try to compute expectation yt, which is coming out to be 0, which is constant. Next, I attempt to find covariance of yt comma yt minus k, and this is coming out in this form. Now, this is clearly independent of time, just dependent on lab. And therefore, we have shown that mean is constant and covariance is also dependent on lag but independent of t. Therefore, this process is also stationary. So many students did struggle in part two. Part one, many of them were able to solve. They did take a lot of time using this methods, should have saved a lot of time, I think, and might have helped in part two as well. So this was question three. Next, question four, a fairly straightforward one. So let me quickly take you along. These are the workings. Again, this is a direct not check the calculations as such, just taken it from students, compared answers of few of the scripts of students, and I found the answers to be similar. So I hope these are correct. In case you observe any sort of calculation error or anything else, please, feel free to let us know to the comments section. I'll be forced to then, perform the calculations myself. But yeah, for the timing, I didn't do them for a few of the questions. I've just used by comparing few of the answer scripts from students who were pretty well prepared. So in part three, we are assuming that we have a constant force of mortality. And when we have a constant force of mortality, remember that mx simplifies to nothing but mu itself. So we can use the value of mx as an estimate of the constant force of mortality itself. We are getting as 95.18% or 0.9518. Next, we have question number 5 from graduation. Again, I'll say fairly easy question. Some of you who might have pre-existing, Excel templates to assist with your calculation, you could simply input the values and calculate them. Although I'm not sure whether that is technically allowed in IFoA exams or not using any sort of templates, but this is something more of your calculation purpose. So you could do that as well. Rest, it's the call of IFoA. I mean, there's no way they would know whether you have performed before the exam or during the exam. So many of you, what I've understood is do use pre-existing templates to, ease calculations, perform them very quickly during the examination by just putting in the input values. So again, this is the extract which I took from a particular student's script. These are the values which I'm getting. Now, it's a Gompertz formula. We have three parameters. So we're going to get 3 degrees of freedom. It's a parametric graduation which is being carried out over here, and that is the case. And for the next part, this is the case over here. Again, zx square is there. Now, therefore, z is this. Now, we need to have insufficient evidence to reject it's not. Therefore, this mod z must be less than 1.96. And here I have performed the calculation. Mod z is less than 1.96. You could either write this statement if I denote this entire mod term as y. Other than that, I can just, take this part over here, square it, and then I'm getting this particular quadratic equation. I find the roots of these equations. Again, you could find them using Sridharacharya formula. Alternatively, using Google, you will find a lot of online calculators for quadratic equations where you need to just input the coefficients of x square, x, and the constant, and they'll give you the roots. So I got the roots using that particular calculator, and then I saw that this particular thing is less than 0 in this particular interval, and therefore x lies between this particular interval. So for the graduated rate to lie in this particular interval, we would be having insufficient evidence to reject h naught. Again, most of the students did find this question pretty easy. Question number 6, again time series. Leaving one student again. No, I didn't find any of the students being able to solve part one of this question. And honestly, this was slightly tricky. But again, whenever you need to demonstrate something, prove that something, good part is what the final solution is gonna look like. That's the easier part. Again, you might be hearing some background noises. So it's Durga Puja time in Calcutta, and it's like probably the best time in the year to stay here. So kindly ignore the background noise. That is something which is gonna stay for maybe a couple of more days, if not only today. So next, moving forward to question number 6. This is what I have in place. And you see, we have been able to bring it in the particular required form. You might pause the video to just, go through the steps and understand the solution. This is part 2 over here. And next for part 3, okay, this is basically for the earlier question. You can ignore this actually. It was for the earlier part. So next, coming to question number 7 from Copula. This was a very scoring question, I will say. So let us quickly glance to the solution for same. Again, a snapshot of a student's answer script itself. part 1, 0.12836, part 2, 0.1253, and then finally part 3. It's coming out to be 0.84134. Final answer is coming out to be 0.12713 over here. Next, we have question number 8 over here, which is from Markov jump. Now here, this is the model. I'd like to highlight the assumptions. I am assuming that on average, deaths or critical illness are occurring at the middle of the year, and therefore the corresponding, zero point 0.5 there. Also, certain lives you'll see that, we started with 849. We started with, if I'm not wrong, how many lives? 887 lives, and 849 were active. 5 of them, took critical illness benefit. 4 of them took death benefit. So the remaining lives, they were kind of censored. Now, because the question explicitly asks to make a three-state model, we cannot bring a fourth state, which is sort of lapse or anything else. So one of the assumptions while drawing the likelihood function is that all the other lives, apart from those which were active or who took critical illness benefit or death benefit, they kind of lapse the policy or something of that form, and on average, did so at the middle of year. So these are the 4 terms. First term is basically for the 849 active policies. This term is basically for the 4 policies where death benefit were given. These are for 5 policies where, critical illness benefit were given. And for the rest 29 policies, which have, kind of got censored, I'm assuming that they got censored on average at the middle of the year. This is the contribution from there. So now if somebody is assuming something else, they might get a different expression, different answer. If the examiners find them correct, they should be getting, they should be giving you marks accordingly as well. This is stating, using the assumptions I have taken. Some of you might take some other assumptions, and that might be absolutely correct as well. So you can perform, find the log likelihood. I have skipped those steps as those are fairly straightforward. Getting to the direct answer, mu hat is coming as 4 by 868, sigma hat is 5 by 868. Next, it is an EPV. This is the expression. It's a 1-year contract which was stated in the question. 15,021 e to the power minus mu plus sigma t into sigma dt. Solve the integral. I'm getting the answer as 85.96. Next, we have question number 9, which is from extreme value theory. Again, here specifically, I'll see in part 3. Most of the students whose answer script I was able to see have made a mistake. That the question asks it should be more than 5%. If we are using the threshold exceedance model, so what we do is x minus u given x is greater than u. So here x is greater than 5%. So x minus u will be nothing but greater than 5% minus u. U in this case is nothing but 2.2%. So what we are looking for here is basically that the random variable which we're using as GPD, that should be nothing but more than 2.8%. So this was a mistake which I saw in most of the scripts, bearing probably one script. Most other scripts had this mistake. So again, I've taken this directly from a student's answer script itself, not check the calculations as such. In case you observe any sort of discrepancy, please let me know through comment section. I'll have to perform the calculation then again. So it's 0.82346. Part 3 here, it's 2.8%. Most of it took 5% over here, and therefore we're getting a different answer. Another way you could have checked this is if you take 5%, the answer was coming out as 87 or 86%, which if you think logically doesn't make sense. To have the probability of losses exceeding 5% as such a high value. I mean, exceeding 5% is a very extreme event. So if you're getting 80-90% value means something is going wrong. So these are sort of sense checks which you can perform while calculating. You need to be very aware of the situation, what is there in the question, which values could be likely or not. The more you practice and the more you practice using your observation as well, the better it is the case. So in this question as well, while I was looking at the scripts, I was also thinking, what is the case. So then I was trying to think from the point of view of students why they couldn't realize this. I mean, the answers were coming as 80-90% taking 5% over here. I'm like, that should have made them think twice. Are they doing something wrong? Such a high answer is coming for such a extreme event, ideally whose probability should be less. So this is the case. And part 4, we are getting this as 0.00018. Again, this is minus 3.57. Some of you could have taken 3 to 4 decimal places, performed interpolation. That is fine as well. So overall, I'll say like the last 2, 3, or 4 sessions, students continue to struggle in CS2A. CS2B was fairly straightforward, leaving the last question, which few of you struggled in machine learning question. But again, that was more about what I understood after discussion with Gunjan was it was more about you applying the basics of our logics. And students who did prepare for that, were able to attempt the question and complete the entire paper. So CS2 among the initial, CM, CV, CS papers remains to be, I will say, the most challenging paper to clear. So here it's unlike the other paper, specifically CM1 or CS1, wherein, even if you have just performed the past year questions, questions tend to be very much similar and you are able to reproduce on similar lines. CS2 is slightly different. You need to apply. Even this paper, I'll say, 2, 3 questions were very different, very difficult. But on the other hand, other questions were pretty much scoring. So candidates of all, have to be extremely well prepared for CS2. And this is that paper which ultimately forces you to build very strong concepts and have strong application skills. At the same time, be observant while you practice. In lot many papers, you can just, be unobservant, complete the paper, clear the paper, maybe even score very high marks. But maybe later on in your practical life, you need to be observant. Even if you're solving, just don't do it blanket wise, just solving the question, moving towards the next question, observe what is difference, what is not. And this helps you to develop an intellectual capacity and, be able to visualize things and be able to visualize what if something else is given differently than how you could have gone about solving that question. So practice, definitely practice a lot, but at the same time, be observant what you practice, try to analyze patterns and all. All this again is possible only if you start with a preparation early, because in case you just prepare 2, 3 months before examination, or you will wait for the results to come out in December and then start with the preparation, effectively you're losing close to 10 to 12 weeks depending which paper you sat in the September term. And it really doesn't make any sense losing such quality time. Start your preparation as soon as possible, and obviously, basis the results, you can again take a call, but no point in wasting those 3 months. Even the classes which we have provided, I hope all of you are aware, we have increased the validity from originally, 2 consecutive academic sessions to 3 consecutive sessions, so that students have now even more flexibility to decide on the papers in case they are not well prepared, in case for working students, certain working projects come up which are going to consume a lot of time, or for ones who couldn't clear their examinations. So they have just more flexibility to choose the papers, they might start preparation for a paper, but later on they, just have more freedom to change their paper. So all these things which are coming out, it's just that, you all start as soon as possible. So we are starting with our live batches from October 9, which is, sufficient time. I'll say exams got completed around 23rd September, if I recall correctly. So it's good 15, 20 days, which is fine. And obviously a lot of festivities are there in October as well. So I'll say, start little bit and, progressively increase the speed, but don't wait till the results to come out, because that is complete waste of time. So I hope that, you all found this video useful. Please do like the video. It helps, to make the video reach to more people across. And in case you have any inputs regarding the content of the video or anything else, feel free to let us know through the comment section. Thanks everyone.